Alright, so this is the example problem 1.4-4 universal gravitation. Two students, they're having issue here when they input. So let's check what you have and how this problem is going. So here I highlighted here, says you have mass 1 is 75, your astronaut, and she weighs 123 Newton. So her weight is towards the center of your moon, and your moon has some mass, so that's your mass 2. And we're trying to find R. And of course we have to use, it said G can be found in appendix C, and we can go in there to take a look at the G value. And then of course we have to use a law of universal gravitation, the equation, to get the radius. So your law is your gravitational force, and then your constant G is in the lecture. So if you read the handout and listen to the lecture, you know this. Okay, and then of course this is R and then square. So this is what we want to find. So what we have to do is two things. One is we're going to move around in order for us to get the correct location. So you just put that over there, and then you're going to put this down here. So you basically just swap this two. So you're going to have something like this in here. And of course, if you want to get rid of square, you're gonna find the square root, of this whole thing. So that's the first thing. You're gonna write it down in your note. And so everything, all the information, wrote it, and we use the equation, universal gravitation law, and your G constant. So this one, you go to the appendix and you read it. So you're gonna get G about G is about 6.67, 10 to the power probably minus 11, I guess. Let me go and check. Yeah, that's relatively around, around there. So 6.67 something times 10 to the power minus 11. My handwriting is not very good. So anyway, that's all we've got. So now we have to calculate. You can plug it in and do your math, and it should come out. The only thing is when you calculate, you're gonna have to change it into kilometers. Because when you calculate it, your unit is gonna go all cancel out, and it will come out usually in meters. Because you're given like kilograms, and then this is meter per second. So when you look at it, this G of course is in meter, I think, minus about meter cube, minus meter cube. So anyway, so if you plug it in just like this, with this constant for G, your end unit is going to be meter. So you have to change that into kilometers. So that's your catch point is right here, is there. So your answer calculation will be in meter, and you have to translate that into kilometers. So I said I'm going to teach you how to use either Python or MatLAB. So I checked their engineering folder, and I found the MatLAB in there. So get a Horizon client, and then use the remote access, go into our folder, and you're gonna find a MatLAB. So the MatLAB, when you open it, you should see something like this. And you're gonna of course put it in a command window. I'm gonna give you this code. I'll copy and paste it for you and upload it so you know how to input, okay, into this computation software. So first we're going to define G. This one comes from your appendix, C. So that's a 6167430. In MATLAB, we write 10 to the power minus 11 with E. So this E means that's 10, and minus 11 is power, So this means 6.67430 times 10 to the power minus 11. Everything that you want to write to explain, we usually use a percent sign. And you're going to see the green, It will turn into green from black. So every time it turns into green in the command window, it means it's just a comment to remind you what that is, in this function. So we define the function. This means we're defining the function. See, Broxville function. And you can also, of course, use a shortcut. So shift plus F1 is going to give you all the functions. So we define the function G equal to, okay, that's our first variable, because your equation is like this. So therefore you have to identify what G is. So we're going to give the value of G first. And of course you're going to write down, this is the most important thing, the unit of G, given to you in the appendix C of your textbook. So m to the power 3, and that's your meter. Actually there's no minus, meter cube, and then kilogram, that's minus 1, power is minus 1. So meter cube per kilogram, and then per second square, So you have I am going to get rid of this highlight, So that is your unit, for G. And then we know the first mass is 75, it's already in kilogram, so you don't have to change it. See, the gravitation is in kilogram, so you don't need to change into gram, you can just simply use a kilogram straight in. And your mass 2 also is given to you 7.347, and then times 10 to the power 22 is given to you right here, 7.347. Instead of 10, we write it like this for the MATLAB command, so e to the power 22. Command means it is communicating your computer how to calculate through this software, So mass of second object is your moon. So here, of course, this is not Earth, we already program this equation, so you can change this into astronaut, So let me go ahead and change really quick for you here, So you can go ahead and change like the S, according to your problem, astronaut, we have a lot of assets, like every time we code and program every equation that I have programmed, I have the code like this, so I don't have to write it again, and I systematically save each page of that, and I will definitely give you a copy of this code to you, and that will be your first assets for MATLAB code. You have to build your own library in programming, You don't have time to write it again and again. Typing from here all the way here takes a long time. So you're going to type only one time. You're going to program only one time. And you make sure that your program works, your script works, your command works. And you're going to keep that, to your SS library. It's your external hard drive or wherever you want to save, Systematically keep them. Some people print it. You can do that too. Print that out, every code that you have ever written for each equation, So you don't have to rewrite it again and again, the same thing, wasting your time. So now I already programmed this. So this is my equation. I square rooted G and 1m2 divided by f, which is this guy I just wrote, If you want to find the radius, you are going to square root G and 1m2 divided by yes, F, which is your force. See, it's already programmed. Very easy. That's your function. So I can call it whatever I want. I can call it like a K or something. But that means that you're just getting radius. So you can write it R. In this case, I wrote it in meters because I know after cleaning out all of this, you're gonna get definitely in meters. But your answer wanted, okay, in kilometers. Therefore, your program, okay, need to put one more step. So here where if somebody wanted in meters, I'm just gonna go, okay, print this guy R meters. If your program wanted in R kilometer, you're gonna print it in, okay, R kilometer. See that? So this means like give me the answer. So F print F. It's just your string is here. The calculated radius is, okay, I'm gonna give it, this is where you change your decimal. So 0.2, okay, F me, just give me as, the number, and we don't want it in this kind of format, which is in exponential, format. So this means like, oh, hey, I don't want it in the engineering, okay, format, which is E. We usually use E. Scientific format is 10 to the power. We don't want that kind of format. Just give it to me. All right, F mean like in regular numbers. All right. So then all you have to do is just enter. If you enter a C, like it's going to give you the answer in kilometers. Because I want it in kilometers. So all you have to just go in right there. Let me kill this. Clean up my mess. And you yes, copy and paste it right in there. So you should get 1729.16, and you get this problem. It's very easy. See, like so every time you get this kind of problem, you want R, okay, radius, or you have to change any of this, okay, according to, of course, defining the way that it should be. So go ahead and yes, calculate, okay, and I already show you what to put. If you use the Excel, you can put this one. Make sure you put it in this way and calculate it, and you should get that, okay. So when you get it, insert right here, and it will give you problem is completed and correct. That's it.